Okay, now we're going to take a look at variables, math, and inputs in Python. First up, variables. Variables are containers that hold a specific type of data, but the data they store can be changed. Data types. First, primitives. There are four kinds of primitives: integers, doubles, booleans, and characters. So the int type stores whole numbers. An example would be 7. They have no decimal. Double stores numbers with decimals, like 6.8. Booleans only store the word true or the word false. That's it. True or false. Characters, chars, store letters, single letters. An example would be C. Objects, the only object we're going to be using at this point are strings, and strings store words and sentences, like Billy Bob. Naming variables. When making variable names, use the following rules. The variable name should start with the lowercase letter. The variable name can only contain letters, numbers, and underscores. A variable name can be of any length. Each word beyond the first should have an uppercase letter or be separated by an underscore. Examples of variable names. Name: 5 underscore ball. Ball 5. World: fantasy underscore world. World 2. Game: game underscore board. Board game. Assigning and initializing variables. Assigning is when a variable is given a value. Initializing is the first time a variable is given a value. Assigning a value to an already declared variable. Variable name equals value. Example, age equals 15. Concatenation: the joining of text and other types of data. The symbol for concatenation is plus. So we could join the number 6 with the words space years old and get 6 years old. Or the words Bob with the words is tall and get Bob is tall. Or the result of 6 plus 7, 13, with the character 3 and get 13 plus the letters or the word 3, so 133. Or we could add the string 3 to the result to 2, 6 and 2, 7, which gives us 3, 6, 7. Now time for math. There's two kinds of math that we can do in Java: binary operations, or operations that have two operands, one on the left and one on the right, like x plus y, or unary operations, operations that only have one operand, meaning there's only one variable. The binary math operators are the following: plus, addition, sums the two operands. 5 plus 3 is 8. Minus, subtraction, subtracts the right operand from the left operand. 5 minus 3 is 2. Multiplication, with the star symbol, multiplies the two operands. 9 times 7 is 63. Slash, forward slash, division, divides the left operand by the right operand. 4 divided by 2 is 2. Modulus, divides the left operand by the right operand to find the remainder. The remainder of 19 divided by 5 is 4. Unary math operators. Minus, sign change, uses the opposite of the value. So the value is 5, it will use negative 5. And if the value is negative 5, it will make it positive 5. Plus sign, absolute value, uses the positive version of the value. So if the value is negative 5, this will make it regular 5. Then we have a plus plus, prefix incrementation. This means that the two plus signs go before the variable. This changes the variable's values by adding 1 to it and uses its new value in the next operation. Plus plus after the variable, or postfix incrementation, uses the variable's original value in the operation and then changes its value by adding 1 to it. Minus minus, prefix decrementation, is when the minus minus is before the variable. It changes the variable's value by subtracting 1 from it and uses its new value in the operation. Minus minus, postfix decrementation, is when the minus minus comes after the variable. It uses the variable's original value in the operation and then changes its value by subtracting 1 from it. Prefix versus postfix. So in this example, x equals 8, y equals 5. Z equals minus minus x plus 5. Because this minus minus comes before the x, we're going to make x equals 7. We subtract 1 from x because of the minus minus. Then we use this 7 in the operation. So now we're going to add 7 to 5. 7 plus 5 is 12. So z equals 12. X is 7 now because of this operation. Y is still 5. And z is 12. So we print 7, 5, 12. Now here's an example of postfix. The minus minus is coming after the variable, not before. So here, when we get to this operation, z equals x, which is 8, plus y. Now, after we register the value as 8, we subtract 1. So we use 8 here. But when the computer gets to the minus minus, it's going to change x to 7 still. So now we have 8 plus 5, which is 13, not 12. But x is still 7, so we print 7, 5, 13. Assignment operators. Assignment operators will both use the current value of the variable and assign it a new one. They all involve the equal sign. The first one is the equal sign by itself, and it changes the variable on the left of the equals to store the value on the right of the equal. Then we have plus equals. It adds the value on the right of the plus equals to the value on the left of the plus equals. Then we have minus equals. Subtracts the value on the right of the minus equal from the variable on the left of the minus equal. Times equals, or multiple equals, multiplies the variable on the left of the times equals by the value on the right of the star equals. Forward slash equals, or divide equals, divides the variable on the left of the divide equal by the value on the right of the divide equal. Here's an example. X equals 2, y equals 5. Y times equals x. what this is effectively doing is saying that y equals itself 5 times x, 2, which means it equals 10. Operator precedence. The first thing the computer will do is whatever's in parentheses. Then the computer will do the multiplication, division, and modulus. And lastly, addition and subtraction. The above operations are done by level, left to right for each level. We skipped one. Here's an example of precedence. We have the following math to do. 5 plus 3 times 7 divided by 4 plus 3 minus 6 divided by 2. The first thing we do is get rid of the parentheses. So the 5 plus 3 will change to an 8, and the 6 minus 2 will change to a 3. Then we're going to do the multiplication and division in the left to right order. So the first thing we do is 8 times 7. That becomes 56. Then we do 56 divided by 4. That becomes 14. Now we do addition and subtraction. The first thing we do is 14 plus 3, which is 17. Then we do 17 minus 3, and we get the result of 14. The good news is that the computer does all the math for you. You just have to understand the order it goes in. It's going to do the first parentheses on the left first, then this one, then the multiplication, because it's farther on the left than the division, then the division, then the addition and subtractions for this left, so this plus sign, then this minus sign. The math class. The math class has methods to perform complex operations and stores an accurate value of pi. Accessing the value of pi. All we're going to write is math.pi. An example of how we use this would be circumference equals 2 times math.pi times radius. Math class methods. ABS with a value finds the absolute value of the received value. PAL with a base and an exponent finds the result of the base raised to the power of the exponent. Random creates a random double value from 0 to 1. SQRT value finds the square root of the value. Math class example. X equals 5, y equals 2. R equals power 5 raised to 2, which is 5 squared, which is 25. Now time for the last part, input. The input class is used to gather data from a data stream. For now, that will be the keyboard. But later on, we can get data from a network, from a microphone, from a camera, anything really. Gathering data from the user is a two-step process. You first have to prompt the user to enter the data, then you gather the data with a scanner method and store it into a variable. Gathering data with the scanner. Format. Variable name equals input, opening parentheses, closing parentheses. Example, input 1 equals input, opening parentheses, closing parentheses. Now let's put it all together and actually code something. So let's go ahead and open up PyCharm. Same way we did last time, we're going to open up Windows File Explorer, click on USB drive D, find PyCharm, click on the shortcut. It's going to load up. Click close. Now it's going to open to the last project we had, which was Hello World. We want to make a new one. So we're going to click File, New Project. Then for location, we want to click here, drop this menu down, right click on it, new folder. I'm going to call this Math Example. OK. Make sure we have it selected now. Press OK. Then press Create. New window. We can close out of the old window. Press the drop-down menu, right-click on the folder, New Python file. I'm going to name it Math Example. So we want to prompt the user to enter in two numbers. Print enter the first number. Then we're going to say input 1 equals input. Then we're going to say print new line, so \n, enter the second number. Input 2 equals input. Print enter the third number. Input 3 equals input. Let's see how it goes. Right click on the file, click Run. Enter the first number. 5. Enter the second number. 2, 3. Then it finished. Now we want to do something with these three numbers. What we're going to do is add them all together. So we're going to make a variable called sum, and we're going to make it equal input 1 plus input 2 plus input 3. Then what we're going to do is we are going to then print sum. So let's do 5, 3, 2. Oh no, we got 532. It didn't add our variables correctly. Why not? Well, the answer is that it's assuming we want a string when we don't. What we want is an integer. So we have to typecast all three of these variables. And it's prompting us to change this away from sum. So we're going to name this clump. And then we have to tell this that we're going to have an integer input 1 plus an integer input 2 plus an integer input 3. And I don't even think we need parentheses for this. All right, let's see if this one works out. 5, 3, 2. It gave us a built-in function sum. So this pointed out that we are still using a built-in function. Something about this isn't registering right with the computer. And what's not registering right is that we cannot tell the computer these variables are integers when we want to add them. We have to tell the computer they're integers when we initialize them. So next to every input, we put an int. This way, the computer knows that all of these inputs represent integers. Then we can just normally write input 1 plus input 2 plus input 3. And then we're going to print the clump is plus clump. Five, 3, 2. Oh, we cannot concatenate here. On line 12, we have to use the comma instead. 5, 3, 2. And there we go. We added the three numbers together. 5 plus 3 is 8 plus 2, and we get 10. Now we can do some more interesting things with these numbers. We could get the power of input 1 raised to input 2. So let's try doing that. We'll only need 2 inputs for this. So we can, instead of deleting it, we're just going to comment it out. We're going to use the Python comments. Then we're going to say that clump equals pow, and we're going to do input 1, comma, input 2. Now we can run this code. And our first one will be 5, and then we'll do 2. And the clump is 25, because 5 squared, or 5 raised to the power of 2, is 25. So hopefully you guys have a good idea about how to go about doing the next set of labs.